nice introduction. And before I start, I also would like to thank your university for organizing these webinars and for inviting me to speak about Carmeuse, mining expertise impacting everyday life. So I will now switch off my camera. If stop video, okay. And we will really start. And so I will split this presentation in, oh, sorry. What's going on? Okay, in two parts. Who is Carmeuse Group? And I will present you the company I'm working for. And then I will switch to the second part, really explaining you what is our expertise, and especially with a special focus on Europe. And then at the end, we will have a question and answer session. So let's start with who is Carmeuse. Founded in 1860, Carmeuse is a global manufacturer of lime, the calcium oxide, and not the green lemon, limestone, mineral-based products, whose you will discover during this talk are used in a variety of industrial, construction, soil improvement applications, and benefits the environment by providing cleaner air and safer water. Carmeuse and its subsidiaries also offer equipment and services to optimize our customers' processes, improve safety, and provide reliable supply. As I just said, the Carmeuse journey started 161 years ago in the western part of Belgium, near the river Meuse, in a place famous for its pure limestone. The company was founded by Mr. Léon Collinet and is still owned by his descendants, Mr. Rodolphe Collinet, the 5th generation, being our current CEO. 20 years later, Carmeuse already operated 3 sites located in the same area, and among them, 2 are still in operation today, the Moa and Angy quarries. From beginning, their ideal location allowed Carmeuse to use different means of transport. You see on the postcard, they are close from the river, so they were able to use boat, ships, but also railway and carts. In 1900, Carmeuse doubled the sites in operation and started to export lime and to deliver other products, crude chemical stone and dimension stone. By that time, the company was also a shareholder in transport firm and explosives firms, which allowed it to obtain lower than market prices. It was a competitive advantage they already had by that time. In 1925, the company is given its current name, Carmeuse, and you find again Meuse, the river name. In between, new sites were added, and first investments were done abroad in Germany and in the Netherlands. After the Second World War, everything needed to be redone, rebuilt. The economic conditions, including an extreme shortage of manpower and a determination to reduce energy consumption, led Carmeuse to mechanize every stage of limestone production from extraction to processing. In 1953, the swan becomes the logo of the company. And you can see here at the bottom, you have the logo. And in fact, it's 3 letters from the name. You have the C for the body, the S for the head, and the M for the back of the swan. During the period from 1950 to 1980, there was inside the company a strong desire to be competitive, and it led to progress in all areas from quarry to kilns. For instance, in 1959, driven by an urgent demand for high-quality lime, Carmeuse was the first company in Europe producing lime with a special rotary kiln developed in collaboration with Polysius and consuming 35% less energy compared to the American rotary kilns, and also having another big advantage, it was allowing to lower the stone granulometry thresholds from 60 millimeter down to 10 millimeter. From the 90s to 2000, the 80s, to 2000, we witnessed the first wave of geographical extension of Carmeuse with acquisition in the US, in Canada, Mexico, Italy, Spain, and Turkey. At the turn of the century, Carmeuse took a new dimension in Central Europe and moved also from a shareholder model to a group model. The period from 2010 to 2019 marks the second wave of geographical extension for Carmeuse, with investment in Oman, Thailand, Africa, South America, and further consolidation in the existing areas. 2020 was the 160th anniversary of the company. Unfortunately, with the COVID didn't allow us to celebrate it as we would have liked, but we know that a bright future is ahead. This is it for the Carmeuse history, and let me now speak about some key figures. So our 2019 turnover was 1.4 billion. We are about 4,500 employees in all the sites. In 2019, we had sales of about 9 million tons of lime. This represents only 3% of the 350 million tons of yearly global lime production. But you have to know that most of this world production is captive, directly used by the producers and not available on the market. On top of it, the main production area is China, with 66% of the world production, while the EU 20 countries and the US represent about 5 to 6% each. Carmeuse ensures about 25% of the US lime production and 15% of the EU 28 productions. To give you another idea of the Carmeuse importance in the lime business, a short comparison with CAO Hélas lime production capacity for this company represents only 3% of our yearly sales. And Carmeuse, on top of its sales of lime, is selling about 35 million of crude products yearly, and is, for instance, one of the 10th biggest aggregates producer in the US. We operate 90 plants around the world and 60 quarries, each of them extracting between 350 and more than 10 million tons per year. And we serve about 13,000 customers globally. Our production sites are located in 25 countries in North America, South America, Europe, Africa, and Asia, and we are really supplying customers all over the world. I want now to highlight some specific sites, emblematic sites, and to start, of course, I will start the tour with these two older ladies in operation since 18 1074, so nearly they will soon celebrate their 150 years of activity. It is the Moa quarry and the Carmeuse, the Moa quarry and Angie quarry. Another emblematic site is the calcite quarry, located in the US, in Michigan, along the Huron Lake, where the extraction started in 2012, and 1 billion tons were mined since then. It is the world's largest limestone quarry, with a total surface of 27 square kilometers, and the mining area itself 17 square kilometers. There we are using two Cat 994, the biggest Caterpillar wheel loaders, having 240 tons operating weight, and loading a fleet of 5 Cat 789, 324 tons operating weight for 100 ton payloads. 180 tons payload, sorry. And to conclude this short tour, a few words about the Brembilla site, where our Italian colleagues moved from open pit to underground in 1993. This is not the only mine operated by Carmeuse. This is the only one in Europe, but we have other sites in the US. But this is the only one using the sub-level stopping method and creating big chambers, 180 meter long, 15 meter high, and 30 meter wide. Now, what are the main processes involved in lime production? As for many commodities, everything starts with prospection in order to identify a suitable deposit, and in our case, ideally made of high-grade limestone. Then the mine design and planning processes defines the proportion of the deposit that will be valorized and how we will mine it. For an open pit, there is then a step which is not on the slide, which is stripping, so the removal of the cap rock, the topsoil, followed by drilling and blasting works, loading and hauling, then crushing and screening. The kiln feed stone, which is usually ranging from 20 to 120 millimeters, is then calcined at 900 degrees centigrade, and at the kiln outlet, the lime will be further processed, can be screened, crushed, or hydrated before delivery to the customers. The lower quality unit, not having the proper chemical content, and the non-KFS fraction, which is below 20 millimeters in most of the cases, are crushed, screened, and sometimes milled and sold as crude product to dedicated markets such as construction. Lime is a versatile product used in many applications, and for Carmeuse, the main market is iron and steel, representing 36% of our sales. Lime is a critical raw material to steel making. In very simple terms, lime helps to capture and remove impurities such as sulfur, phosphorus, silicon, and various oxides contained in the iron ore, the coal also, and the scraps. With the so-called basic oxygen furnace process, producing 1 ton of steel will require 125 kilo of limestone and 100 kilo of lime, while with the electrical arc furnace process, 50 kilo of lime and no limestones are needed, except in the pellet production, where the limestone consumption will be something like 20 kilo. The second market for Carmeuse is civil engineering, with 14% of our sales. Soil liming allows the stabilization of subgrade materials having poor engineering characteristics, while adding hydrated lime and filler in asphalt gives to the pavement higher mechanical performances and improve resistance against severe atmospheric conditions. The third market is flue gas cleaning, where lime or limestone are used to remove the sulfur oxides from the gases emitted, for instance, by a coal power plant. Many building materials are made of lime or limestone. It is, of course, the case of lime mortars and rendering, but not only. Limestone aggregates are often the concrete skeleton, and limestone fillers are frequently used in substitution of cement. The production of autoclaved aerated concrete, the so-called heat tongue block, uses control reactivity quicklime. Lime is also essential to water treatment for pH correction, but also for precipitation of dissolved metals, phosphates, sulfates, or fluorides, remineralization of the water, decarbonation of excessively hard water. Lime is also used in sludge and waste treatment, stabilization, to limit the odors, to eliminate the pathogens, etc. In the chemical industry, lime and limestone are used to produce sodium carbonate, calcium salts, to make numerous organic products such as propylene oxide or glycerin, for calcium carbide, which is used to produce acetylene, to produce glues and gelatins in a traditional way from abattoir waste, to tan skins, to condition drilling sludge in petrochemistry, in carpets, rubber, and plastics production. The non-ferrous industry uses lime to separate the ore from impurities in many processes. In agriculture and forestry, lime and limestone improve soils. Lime refines sugar by precipitating mineral and organic impurities. Pulverized limestone is a calcium additive in animal feed. Lime and limestone are used in milk powder for babies, chewing gum, yogurt, soft drinks, shrimps, and fruit preservation. And finally, lime and limestone are key products for paper and glass production. As earlier said, beyond lime, Carmeuse and its subsidiaries have a large expertise in geology and mining, in operations, of course, supply chain, and we are offering equipment and services to optimize our customers' processes, improve safety, and provide reliable supply. I am sure that now you understand better how we are impacting everyday life. It is now time to switch to the second part of the presentation, dedicated to the mining expertise within our European operations. So Carmeuse in Europe, it is 32 sites located in 11 countries, organized in 6 entities, each of them being responsible of its P&L. So we have these 6 entities. We have what we call Western Europe, with France, Belgium, and the Netherlands. The second one is Italy. Then we have Czech, with Czech Republic, Slovakia, and Hungary. The fourth one is the Balkans, with Bosnia and Herzegovina and Serbia. Then we have Romania, and finally Turkey. Within this area, we mine about 15 million tons per year, and we are producing about 3 million tons of lime. The mission assigned to the mining team is to ensure a sustainable extraction of Carmeuse resources with agility in a fast evolving business environment. What does it mean? What does it mean for us? We often operate in densely populated areas and must adopt the best available practices. The resources are rare and accessing them is more and more complicated. We must therefore get the most of our deposits and have very selective extractions, maximizing the recovery. In Europe, there is a lime production overcapacity, generating strong competition, and we have to adapt promptly to fluctuating economic conditions. The mining team is covering all the steps from mine design to product crushing and screening. And to cover it, we put in place a so-called nesting dolls organization with a light EU corporate team led by me and based in our headquarters in Louvain-la-Neuve and in charge of the long term, the strategy, the coaching and the training. We have then the area mine engineers in charge of the midterm mine plans and involved in specific projects and improvement initiatives. And then we have the quarry managers and their team executing the one-year plan, defining the detailed mining sequence, and organizing and monitoring all the production steps. This organization promotes strong collaboration between the different teams and leaves space to all for initiatives. Within Carmeuse, we are convinced that investing in the best technologies gives us a competitive advantage, and we really embrace innovation. It is true in all the mining steps where we already implemented advanced solutions and are still testing new ideas. We are, for instance, using Vulkan for more than 25 years for geological modeling and mine design. We invested in semi-autonomous smart drilling rigs. We are using the best available technologies like 3D laser scans or drones for blast preparation. In Belgium, for more than 10 years, all the shots are done with high accuracy electronic detonators, and for increased safety, the teams are equipped with remote blasting console. We are, of course, tracking all our fleet and stone line performances, and we are following the particle size distribution of key products in real time. Here is our geomin process. As already said, everything starts with prospection, and a good understanding of the regional geology is key. Once the targets are identified, a detailed field work coupled with 3D DTM data allow to have a preliminary geological model. Our next classical step is then to perform geophysical investigations in order to identify possibly altered parts of the deposit, and then to start core drilling and stone testing campaigns. All these data are then combined to build a detailed 3D geological model with embedded geochemical data. This model and other sources of data, like a geotechnical model, hydrogeology, of course, the constraint from regulations and permitting, and the mining best practices and the future equipment are used to build, on top of the geological model, a final design that is used to evaluate our reserves and resources. Afterwards, a life of mine planning meeting the market needs, both in terms of quality and quantity, is finally issued. And so we always play with different time scale, starting from the final one and stepping back to the shorter term, sorry. Moving from the life of mine to the very short-term planning requires a lot of input and generate many outputs. So we have all these input on the left. And it is, for instance, key to schedule well in advance the land acquisitions, to have a good byproduct management, because we will generate byproduct. Even if we try to recover as much as possible, we will always have some part of the deposit that will not be suitable for any application. We need to be sure that we have space to store it and to identify it well in advance again. To identify areas that can be reclaimed. It doesn't make sense to keep all the pit open and not to restore area as soon as they have no more added value and nothing more to mine in it. And of course, we need to have, at the end, very detailed production and blasting schedules fitting with the allocated budget and also, again, the customer's expectation. Here is something important and to keep in mind if one day you are involved in mine design. Great tools exist, like Vulcan. They are available, but they are there to assist in the mine design. But it is really the person doing the design that controls it. Even if there is automatic tools, it's really the person who is driving the process. Most of the time, a pit design has several end purposes, like determining ore reserves, defining the life of mine, with the location of the infrastructures and all of that, and providing guidance to the team in charge of the shorter term. For a company like ours, it is very important that the people in charge of the design bear in mind our values of safety, no hazard in the design, long term, no high grading, no easy solution, just taking the white bread, respect, limiting the environmental impact, efficiency, for instance, by planning productive, well-designed all roads, and customer focus, problem anticipation, no surprise. Of course, the process is complex, and coming up with a satisfactory design may require several attempts, and it is very important also to document all the principles, the reasoning, and to make running notes that will be later on used by other teams to understand why we did that. It is key to document well all the documents that and all the ideas that were put in the mine design. Before starting any project, it is also key to know the general expected pit design parameters by material type. We might have several types of material, like stripping versus the bedrock, and or geotechnical domain, from the required buffers along the license boundaries to the desired space for maneuvering and search piles at crusher. Each project has its specificities, but here are the typical parameters used within Carmeuse when working with CAT 775 and CAT 988 range of machine. 10 meters along the license boundary is really a minimum to prevent impacting neighbors' properties. Keeping berm and adding extra wide safety berms every 3 benches limit the risk of injuries caused by falling rocks. 80 to 75 batter angle gives a good blasting throw and limit the risks of ballistic long-distance fly rock. Limiting the bench height to 12 meters reduces the all deviation problems, facilitate the blasting, we can do full column charges, and allows the full scaling with an excavator when required. And for efficient loading and hauling, you need enough maneuvering space and low-grade roads. As I said, we are always keen to evaluate innovations and to adopt the most relevant for our business. In drilling, for instance, we are using GNSS on the rig for accurate semi-autonomous positioning. You see, we have the 3 captors on the machine, and we are using its RTK system with a SIM card inside the machine. So we really, from the laptop of the blast surveyor, we can extract, from the blasting software, the location of the holes, the drilling angle, the drilling azimuth on a USB key. We go to the machine and the machine comes to the area, and then the setting of the machine is done automatically by itself. The operator in the machine is there to drive the machine nearby the next shot, but then the positioning, the final maneuvering is managed by the machine by itself. We are also testing the monitoring while drilling in order to correlate the fluctuations of the drilling parameter with the rock mass. Here is an example from a French quarry where we correlated the penetration rate fluctuation with the driller perception. Combining these data with the benches observation allowed us to conclude that penetration rate below 40 meters per minute corresponded to hard compact rock, and the opposite, a penetration rate above 60 meters per minute, was synonym of a much softer rock. We are now using this data for blast optimization. We have a lot of chemical specs in our product, and of course we need to control the quality in different places, from geological modeling until the final product. And we are used to collect samples of our blast holes. And to collect better samples of our blast holes, we invested in automatic sampler located on the disdusting cyclone of the machine. We are also using deviation probe for safe and efficient blasting. With such a probe, we will have the 3D hole trajectory. This is useful, for instance, to prevent fly rock caused by a too high explosive energy at the bench of the tool due to frontal deviation and reduced burden thickness. In Carmeuse, Europe, in most of the sites, we have an internal staff dedicated to blast preparation. We perform about 1,250 shots per year, and we really want to be references in that field. Therefore, in the quarry, we are using GPS, 3D laser scan or drones to collect accurate volumetric data to prepare the shot. We are then using dedicated blast preparation software, helping the team to set an optimized drilling pattern and to identify risky zone. And you see here you have the profile with the real face, and this is the hole as it is drilled. And you can identify that you have a shorter burden in that area and that you should decrease a bit the explosive energy to avoid a fly rock. And during the execution, as I said earlier, we are really for years in Belgium using electronic detonators. In the other area, it is most of the time nodal, but we are using remote consoles we are using bulk explosives. Each of our blasts is recorded for further analysis. We use seismograph to control the blast-induced ground vibration, and we are using this data to build predictive models. In every site, the key performance indicators are tracked by the local team. For the yellow machine, we work with the telematics solution developed by the suppliers to facilitate the tracking and the reporting. Once per month, the data are uploaded in our SAP and later used for benchmarking exercises. Here is an example for the front-end loaders, the one working really at the face, showing that in most of the sites, the percentage of idling time, so the engine is running, but the machine is not productive, it's idling, is higher than the CAT benchmark of 20%. This is an improvement identified we are currently working on. In this second example, it refers to the productivity of dumpers from 5 sites using the same type of dumpers. And we see that the site conditions are really strongly influencing the fleet performances. And if you look between the worst performer and the best performer, those two sites, they are mining about 2 million tons per year. But the worst performer has a fleet 2 times bigger than the best one. And that's where, again, good design pays. Most of the current lime kilns, as I said also earlier, run with tones ranging from 20 to 120%. This is the reason why, as lime producers, we are always trying to reduce the percentage of fines below 20 millimeter generated during the different mining and processing steps. For instance, we can save 5% by playing on the blasting parameters. We can save 15% by using a double roll crusher instead of an impactor. And we can save 10% with good stockpile management. Safety is also at our core. Any incident is analyzed, the conclusions are shared with all the sites, and corrective actions are deployed. Here are 2 dumpers accidents that happened in our sites about 10 years ago. In the first one, the top one, the driver drowsed and exited from the road. Fortunately, one of the boulders you see between the wheels, marking the edge of the wall, surrounded by a muddy material, stopped the dumper before it falls in the pit. In the second example, after wrong maneuvering, a dumper climbed on a low-grade burn and was overturned. Based on these 2 accidents, we defined a standard with a boulder on the roadside, but this boulder is covered by a pile of material that will play like the mud did, will stop. A boulder is not sufficient to amortize the shock. It will be pushed away with the pile behind at the back. You will avoid to have the boulder pushed away. And with the boulder on the roadside, you will avoid to have the truck climbing on the low-grade slope. And of course, if you do such a berm, you need still to keep some opening for all road drainage, but the opening must be regularly spaced, but narrow enough to avoid to have a lighter vehicle that could pass through the hole. We contribute also to nature protection, and several Carmeuse sites participate to the Life in Quarry initiative, creating a biodiversity network in the quarries. So it is really this idea that you can Of course, quarries are already a special territory for pioneer species, but you can, by some actions, increase the biodiversity and the interest for these species. And so we have, for instance, one project of this type in our Moa quarry. Everything starts with a zero state inventory. And you see that this zero state already shows the great interest of a quarry site. And then with specific actions, creating some special ponds, having some area for grassland and all of that, you can increase the biodiversity. And so the zero state was done 2 years ago. And in 2020, indeed, we have new species that appeared around the quarry. When reclaiming our sites also, we dare to think differently by creating wetlands or fields. So really it's a field that was rebuilt on top of one of our waste pile. We are also investing in renewable energies and are operating 2 of the biggest Belgian solar farms, one in Moa with 13,200 panels, and one in Ezemont with 8,800 panels. These facilities are supplying 15 to 19% of the plant daytime electricity. Thank you very much for listening to me. I hope that I was not too boring, and it is now time for you to shoot your questions. Thank you.